So as we have seen last time, one of the connection of resistors, which is the series connection of a resistor, in which we have seen that when the two or more than two resistors are connected in such a way that the electric current passing from that is same, means there is only one way to flow of electron, but the voltage drop in each resistors are different. Then it is known as series connection of resistors. And not only that we have seen, if we use a three or more resistors in a series, then we get a equivalent resistance, which is R is equal to R1 plus R2 plus R3 plus up to the order. Then you can take a R4, R5, R6, R7 like that. Means you get equivalent resistance by taking the addition of all the resistance which are connected in series, and from that we get the total resistance in a series connection is always more than the highest resistor used in a circuit. Means you can use this connection for increasing a resistance of a circuit, and you can decrease the electricity which is flow from the circuit. Understand? So today we are going to see the another connection of a resistor, which is a parallel connection of resistor. Parallel connection of resistors. What is a parallel connection? You can easily understand it by a figure in which there is one resistor like that and there is a battery. We are using a battery of V volt and a key. So here it is V volt. The key is closed, so electricity will flow from it, and here is the electric current which is flow from it, which is I. And there is a more resistor which are connected in parallel. You can see it here, the resistors are in parallel. So you can see that the wave for electric current is more than one. The electric current will divide it from here. There is a more than one ways for flow of electric current. If we think that the resistors are R1, R2 and R3, and the current flows from the branches are I1, I2 and I3 respectively, right? So here it is a parallel connection of resistor, in which the resistor which are two or more than a two connected in such a way that the way of electric current is different. The way of electric current is not one, but it is more than one. But as the electric current is divided, a total voltage drop is same. In a parallel connection, the voltages are same. The voltage drop is same. While the electric current passing from it is a different. Understand what is the difference between series and a parallel? In a series connection, I is same while the V is different. But in a parallel connection, as all the resistors are parallel to each other, the voltage drop in all of them are same. But the electric current which is passing from all branches are different. As you can see here, the R1 has a I1, R2 has a I2 and R3 has a I3, which is the electric current and which are different from each other. Not only that, from that you can say that a total electric current is a summation of I1 plus I2 plus I3, because these are the part of I. Before divided, the total is I, and at this point they are divided into three different branches, and then they get combined at here and again becomes a I. So I is the I1 plus I2 plus I3. Exactly opposite to the series connection, where we are using V is equal to V1 plus V2 plus V3. Now we are going to use one another circuit which has a battery of a same volt, which is V. The key is same, the internal resistance of it is a same. So the key whole battery is same. Here it is key. The battery is of V volt, and we are using only one resistor R. And after that, the electric current passing from it is I. So I and V are same. So you can say that the R and the combination of this one is same as we have seen in series connection. So it is known as the equivalent resistance of a circuit. So R is the equivalent resistance. So R is the equivalent resistance. And if we are using the Ohm's law on this circuit, then according to Ohm's law, what is the equation? The equation is V is equal to IR. But as you know that in our first equation there is an I in whole equation. So at here we have also used a I. So for that we can say that the electric current passing from R. What is the electric current passing from R? It is I. There is an I current, so it's a I is equal to V upon R, which is the equation number 2. The same like that, we can say that the electric current passing from R1, which is I1. So I1 is equal to V is same, but the resistance is different. Now the electric current passing from R2 is I2, which is V upon R2. And the electric current passing from R3 is I3, which is equal to V upon R3. Here it is equation number 3. Now put the value of equation 2 and 3 in 1. Then instead of I am just putting V by R. Instead of I1, there is a V upon R1. Instead of R2, V upon R2. And for I3, it is V upon R3. Now what is the common in this equation? Our equation has a V. So take it as a common. So V by R, at here V. Then the remaining one is 1 upon R1, 1 upon R2, plus 1 upon R3. The V's are cancelled out. So what is our equation? 1 upon R1 is equal to 1 upon R2. 1 plus 2 plus 3. So here it is the equation for equivalent resistance. What is the equation? That the reciprocal of equivalent resistance of a circuit is the addition of the reciprocal of all the resistors connected in a parallel. If you want to find out the equivalent resistance, then first of all you have to find out the reciprocal of it. When you get 1 upon R, then you have to just invert it. Bandar ki tarah pultit karwa, right? So you get the value of R. But for finding R, you have to first of all find 1 upon R from this equation. So 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So you can say that in a parallel connection, the reciprocal of equivalent resistance is the addition of reciprocal of all the resistance connected in a parallel. Once again we will see it. Then what is the parallel connection of a resistor? Then when two or more than two resistors are connected in a circuit such a way that the wave for electric current is more than one, but the voltage drop in each resistor is same, then you can say that it is a parallel connection of a resistor. If you are thinking that there is a three resistors R1, R2 and R3 are connected parallel with the battery V1 and the K. The electric current passing from it is I, but as it is a parallel connection, the voltage drop in each resistors are same, which is V, but the electric current passing from each resistors are different. Suppose we think that the electric current passing from R1, R2 and R3 are I1, I2 and I3 respectively. Then we can say that the total electric current passing from the circuit is I, which is I is equal to I1 plus I2 plus I3. Equation number 1. Now if we connect a whole circuit with only a resistance R and after that the electric current passing from that circuit is I, then you can say that the R is the equivalent resistance of parallel connection. So if we apply the Ohm's law on it, then you get V is equal to I. So the electric current passing from resistor R is I is equal to V upon R. So like that, for R1 it is V upon I1 is equal to V upon R1, I2 is equal to V upon R2, and I3 is equal to V upon R3. Now put the value of all of them in the equation number 1. You get this one. Now take a common V, then just remove it. Right? They are cancel out. So you get 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3, which is the equation for the equivalent resistance connected in parallel. So what is the conclusions of this connection? The first conclusion is that the voltage drop in each resistor is always same. When the resistors are connected in parallel, the voltage drop in each resistors are always same. But the electric current, total electric current passing from the circuit is the addition of electric current passing from each resistor connected in parallel connection from this equation. Understand? The third one is that the reciprocal of equivalent resistance is the addition of reciprocal of each resistor connected in a connection. And the last one is that a total resistance, or you can say that the equivalent resistance of this parallel connection is always less than the least resistor used in this circuit. In a series connection, you get the highest resistor, but at here you get the least resistor, less than the least resistor connected in it. For an example, if we are taking here it is 5 ohm, a 10 ohm, and a 15 ohm. According to this equation, 1 upon R is equal to 1 upon 5 plus 1 upon 10 plus 1 upon 15. A total LCM is 30. So it's a 6 plus 3 plus 2, 11 by 30. So it's a 1 upon R. So the R is equal to 30 upon 11. So R is equal to 30 by 11. 11 2s are 22. 8 0, 11 7. So it's a 2.7 and something, which is less than the least resistance. Least one is 5 ohm. So you get a less resistance by the parallel connection. What is the need of this type of connection? If you want to just control the electric current, then you can use a less amount of electric current in it. If you want a 5 ampere, then why are you connected it with the 7 ampere? Just connect with the 5 ampere. Does not need to control that. If you want a less, then you do not need to use a higher resistor or series connection. If you want a more current, then why you need to connect the parallel connection? You can use that type of source. The main problem is that our all electronic circuit has a different component. Just see the controller of a TV, means a remote. In this circuit also there is so many components used in it. In a circuit of a TV there is so many different types of components, and all the components are working on a different electric current. So what is the meaning of that? That we have to use a different sources in each component? Then how many sources are used in it? It becomes more complicated. And how can you use that many types of sources in each connection? That means if you are using a TV and all the components has a different source, then there is so many plugs, and you have to use all the plugs in a different value of current. It is complicated for you that how can you understand that in which word that you have to use a which plug. Like हमारा फ्यूज उड़ जाएगा ना, पता ही नहीं चलेगा किसमें कौन सा फ्यूज है. जैसे हम लोग कभी कभी वो स्पीकर्स और ये सब जब कनेक्ट करते हैं, सिर्फ हमें सिंपल कनेक्शन करना, तब भी हमारा दिमाग चकरा जाता कहाँ पे डालना है ये. तो अगर टीवी में इतने सारे कनेक्शंस हो गए, इतने सारे सोर्सेस हो, तो हम कैसे मैनेज करेंगे? सो दे हैव जस्ट यूज्ड अ वन सोर्स. It's a 230 watt, right? And according to the need of electric current, you can use a series or a parallel connection. If you want a less current, just connect a resistor in a series, then you get a less current at them. If you want a more current, then just connect them with the parallel and you get a less resistance and the more current can be flow from it. Just because of that, there is a different type of combination of resistors are here to fulfill the need of amount of electric current in each and every circuit, which gives a better efficiency of component in it. Just because of that, the series and the parallel connections are there. In our house, we are using a parallel connection of electric circuit. What is the reason behind it? What is the reason behind it that we are using a parallel connection of electric current? So for that, we are going to see the drawbacks and what we can say that. So series and the parallel connection, how much useful for us and how there is not how many drawbacks of it that we have to just learn, right? Like what are the merits and what are the demerits of it, right? So we are going to see now merits and demerits of series and the parallel connection, right? The merits and the demerits of series and the parallel connection. So first of all, we are going to see about the series connection, as we have seen firstly a series connection, right? So first of all, a merits of series connection. What are the merits? What are the merits of series connection? The first of all, in a series connection, when resistors are connected in series, a total resistor increases. Right? When the resistors are connected in a series, then you know that the resistance becomes increases as it gives a higher value of resistance. So the electric current decreases. Electric current decreases. As the resistance increases, the electric current is decreasing. So we can control. Electric current. Generally, control means that you have to make it less, right? So we can control the electric current by the series connection. That it can decreases the amount of electric current flow from the circuit. So here is one of the merit of it, that you can control something, right? Because controlling something is a very important thing, right? If the water inside of river cannot be controlled, then it is known as flood. Understand? So if it is in a control, then it is good for the villagers who live near to the river. So the control is the important thing for us. So like that, you can control the electric current with the help of series connection. Now, the second one, the fuse is always connected in series with main voltage line. It is always connected in series with main voltage line. So whenever short circuit occurs, it saves the apparatus in our home. All the electric apparatus are saved by the Understand? So it is connected in series with the main voltage line. So therefore it saves an electric apparatus during short circuit. During short circuit. Whenever the short circuit occurs, the high amount of electric current flows from the whole circuit. But before it reaches to our house, it needs to be passed from the fuse, which is connected in series with this circuit. With this whole one, it is connected in series. So whenever more electric current is passing from it, this fuse wire is just melt. And as it melt, the whole circuit breaks. So that much electric current will not passes from it. And all the lights are closed. So that electric current can't be reaches to our apparatus, so it will be safe. Sometimes the people, the fool people, what are they done? That the fuse wire is little bit thin, a copper wire, thin copper wire, something thin or lead, right? But they are using a thick copper wire that it can be made with a small amount of electric current. But due to that thick wire, a more electric current can be flow from it. And during short circuit, if it does not melt, it diffuses the apparatus of your house, like a TV, refrigerator, AC or something like that, right? But I think they think that the fuse wire is more costlier than the TV, because nowadays the TVs are generally of 48,000, 65,000 or 85,000, while the wire, a fuse wire, is more costlier. It's about 20, 25, 30 rupees or 40, 50, or if you want a more than 100, 200 rupees, right? It is more costlier than the TV. If the TV is just fused, does not need to worry about it. You can easily purchase it with 85,000 rupees. But a fuse wire is, it is 100 rupees. Oh, it's more costly. That much for people are. But actually that fuse wire should be a thing. It should be a thing. That the electric, whenever the electric current flows from it, if amount of electric current is increases due to a heat, it should be melt. And if melt, then it saves the apparatus of your house. So it is one type of merit of it. It is not a drawback, right? It is a merit of it. So the fuse is always connected in a series. There it can save the electric apparatus of our house. Now the drawbacks, a demerit. What are the demerits? The first of all is that in a series connection, total voltage in a series connection, generally the total voltages are divided in a different apparatus. So in a series connection, the total voltage is divided in all apparatus connected in series. Connected in series. So they cannot work with full efficiency. They cannot work with the full efficiency. Like if we are using a 3 bulb of a 240 watt and they are connected with the main voltage line of 240 watt. Each bulb needs a 240 watt and the 3 of them are connected with a 240 watt. Then all the bulbs get 80 watt, and just because of that they are not lights with the full efficiency. They are just faded. they are not that much bright, which is the actual efficiency of the bulb. For an example, if you are just eating a 10 rotis in a whole day, I am saying about the whole day. So it's a 10 roti is not enough for you. I know that you are just eating 50 to 60 or sometimes 100, right? But just think that you are eating a 10 rotis in a whole day, right? It's your, and when you get that, then you can easily work or with a full efficiency, okay? But at some days or in a whole year, there is a one day on which you get only a half roti in whole day, nothing more than it, not a single particle for eating. There is only a half roti. Then what happened to you? You just feel weakness and you do not want to work. You become lazy and sometimes you will become ill also, sick also. It means you can't work with the efficiency because you do not get that you want. Like that in a tree bulb. They want a 240 watt, but now they get only 80 watt. So they are not work with the full efficiency. Understand? If in series connection one of the equipment fails or diffused, right? One of the equipment is fails, then whole circuit will short. Then the whole circuit will short. Then the whole circuit will not work if one of the equipment fails, right? Like there is a 3 bulb are connected in series like that, okay? If one of the bulb is just fused, then as I have said in a first lecture that for the electric current, flow of electric current, there should be a closed part of it. But at here it is open, there is no closed part. And just because of that, they will not light up. The other two can't be light up also. Because of there is a break in a circuit. The electric current will not flow. The electric current knows that there is no way to go. Then how it wants to go there. Just because of that, other tools will not also work. So here is the one of the drawback. Understand? But in a parallel connection, generally, if one of them diffused, after that the other will work. But at here, not a single bulb will work. Right? And the last one is that the resistance is increases. That the resistance is increases. The energy, waste of energy is increases. As the resistance is increases, the waste of energy is also increases. Due to the increment of resistance, the energy wastage is also increases. So here it is the merits and the demerits of series connection. Now in the next lecture, I will tell you the merits and the demerits of parallel connection. Then we will see the difference between both of